Hello, everyone. Welcome to the Shuttle Podcasts. I am your host, Echo, and
I'm Nick.
And welcome to episode 6. Got quite a few topics in store, some sad, some very optimistic. But I guess I'll just go ahead and address the elephant in the room. Nichelle Nichols, known for her role as the iconic polyglot communications officer Nyota Uhura in Star Trek The Original Series, a show which Nick and I certainly take inspiration from, is unfortunately no longer with us. Nichelle, just a quick overview of some of her best achievements, I think. Nichelle, from 1977 to 2015, was a promoter in NASA's programs and a recruiter of female astronauts and astronauts of ethnic minorities. She was such an important beacon of human progress that for her inspiration, asteroid 68410 Nichols is indeed named after her. She will be dearly missed. Per ardua ad astra.
Yeah. Nichelle Nichols, I actually don't know that much about her, but she will be dearly missed. I liked her character, I guess, partly because, even though Gene Roddenberry, thirst baited all of the female characters, or used them as thirst bait, he still, made them intelligent, they weren't just stupid females, I guess. They weren't, sex objects, they were intelligent sex objects, I guess. So I really like that because, he gave her competence and agency and shit like that. Which, I don't know, for a show of that time, of course, it's unique. Among the few, I suppose. As well as Star Trek, the original series, was very progressive for its time. So I can appreciate that, even if it is a bit archaic by today's standards.
Mm. Yeah. Nichols had a lot of stories about actually pretty much every cast member of TOS can have a plethora of stories about just how many people they inspired, but especially because of what era it was, mid-20th century America, and you have African-American woman that is one of the most important members of the ship because they run into a lot of shenanigans and need, communicating. Yeah, I'm very happy that she had the impact that she did, and that's pretty much all I have to say.
Good actor, good character, and
good human.
Yeah, and it says here that she lived to the ripe old age of 89, so
yeah,
a long, healthy life. Shall we move on?
Yeah, you can go ahead with your points because I know you have a higher quantity.
Oh, and also before we start, I would like to announce some big news to the podcast. We have a website. It is shuttlepodcast.space. That is shuttlepodcast.space, not .com, because that was taken despite the fact that the domain isn't even being used.
And it would be lame.
And .space, it's only $20 a year to maintain that domain. And it's space. This is a podcast about space. It's completely appropriate, This was a podcast about baseball and we did that. It would be lazy and it would be cheap, but it's a podcast about space, so it's appropriate. Anyway, yes, so and on the website we have merch. We have merch. I made a merch store, and I added our little picture that we have, the little picture for the title of the podcast, that astronaut walking on Mars. That is on a whole bunch of mugs. It's on shirts. I haven't bought any of them, but people that get stuff through redbubble.com say that their stuff turns out really, really good. And maybe I'll buy them. I really want a mug, to be honest. I think the mugs look great. I might actually get one before next episode. And we have a Patreon and all that jazz, so check it out. Anyway, yeah, I guess I'll start. So, we now know why Ceres is geologically active. Probably. I say we now know because the model that they came up with explains it very, very well. But, of course, we haven't been there. So, I guess we have been there. We haven't been there to figure it out. researchers at the Virginia Tech College of Science used a bunch of data from the Dawn mission, and they developed a model that explains the geological activities. So essentially, the model hypothesizes that the radiogenic decay of radioactive elements such as, but not exclusive to, uranium and thorium, heated up the interior of the planet when it was dead until it got super like wonky and unstable and all that jazz. It still is being affected by the radiogenic decay, but it's also self-sustaining, at least according to the websites that I read. The model could also explain a whole bunch of fractures on the surface of the planet. That's why the model works so well, because it explains other things. According to Scott King, which was one of the researchers on that developed the model, he says, quote, "It turned out that you could show in the model that where one hemisphere had this instability that was rising up, it would cause extension at the surface, and it was consistent with these patterns of fractures," unquote. Evidently, this is quite similar to Uranus's moons, whatever. Evidently, this is quite similar to the moons of Uranus, and according to King, quote, "Some of these moons are not too different in size from Ceres. I think applying the model would be really exciting," unquote. So, I'm interested in seeing if they come to any more discoveries with that model, but I found this really exciting, partly because I believe I spoke about this last episode. Ceres, something about the Dawn mission, I, of course, can't vividly recall because my memory isn't renowned, but I found this to be really cool, that radioactive isotopes are made a planet geologically active just from being radioactive. I thought that was nifty.
Mm-hmm. I know I brought this up plenty of times before, but one of the prevailing theories for a while about the origin of the moon that was meant to account for why we had the same elemental isotopes in our soil was that the moon, during the time that the Earth was forming and during its early years, there were a lot more radioactive particles. So basically what happened is that it just kind of spooted out another planetoid. And it's kind of interesting to see that idea resurface there in, frankly, I think a more sensical area.
Spooted out.
Yeah.
Don't think I've ever heard that phrase.
That's the jargon.
The jargon, yeah. That's the jargon in the astrophysics community.
Don't look it up, though.
Don't look it up. I'm going to.
Don't look it up because you won't find anything on it. It's in the ether of.
Oh,
I'm working
according
on
to
getting it
Urban Dictionary.
Uh-oh.
Okay.
Oh, okay. Don't look it up, please.
There's a lot of different definitions here. All right. Well, closing out of that. Yeah, the moon. I was not aware of that theory about the formation of the moon. The theory I was familiar with was that something crashed into the Earth when it was early in formation, and then something broke off, and the moon was formed. Mm. Would you like to share a topic now?
Sure.
All right.
Actually, you go, because the two ones, the Super Earth and the other one, were both James Webb things. I thought they would go nicely together.
Well, here's something that is certainly interesting. It's not really concerning, but it's it's interesting. June 29th, 2022. You may remember this day as being a normal day, but astrophysicists remember this day as being the shortest day ever recorded. Now, by an atomic clock, that is, because we started using atomic clocks in the 1960s, and June 29th, 2022 was completed in 1.59 milliseconds, under 24 hours on that day.
No wonder I was tired the next morning.
Yeah, I didn't get enough sleep. I lost. It's like daylight savings. You know, we need to add a leap 2 seconds. Anyway, the normal amplitude. Excuse me. According to HSE University Associate Professor Leonid Zotov, this is a Russian university, so this is obviously translated. Quote: the normal amplitude of the Chandler wobble is about 3 to 4 meters at Earth's surface, but from 2017 to 2020 it disappeared. Now I don't know what the bleep that means, but
I think that's the first F-bomb we've ever dropped.
But it means that the Earth's spin has been short since 2017 to 2020. So that's nifty. So Professor Zotov told that to timeanddate.com. Apparently they wrote an article about it. It was suggested, I don't know if it was by them or by the professor, that it may require an introduction of a negative leap second measured by atomic clocks synced with solar time. And solar time is the movement of the sun through the sky from sunset to sunrise. Usually solar time is measured in French decimal time, but not always. So that's, interesting stuff.
This was Earth rotating around its own axis, or the same point in Earth?
I think that depends on what Chandler wobble is. let's. I will do a
Urban
Google
Dictionary Chandler wobble.
Urban Dictionary. Small deviation in the Earth's axis of rotation relative to solid Earth. The Earth rotating, I guess, which was 23 hours and...
Oh, completed one spin. Yeah, okay, so it's per axial day. 3,600 times 1,000.
3,600,000, yeah. Okay. So that would be 23 hours and 3,599,941 milliseconds. Yeah, crazy stuff. And I mean, we've been recording time since, we've been recording atomic time since the 1960s. So the fact that this is the shortest day ever recorded since 1960, who cares, man? Like, I'm sure there's been shorter days between like 800 and now. And I mean, you could blame it on global warming, but this trend isn't predicted to continue. It's not predicted to be a trend, even.
Though that is, I'm very glad that we're able to measure to that precision, because atomic clocks really changed the game for a lot of things. They were used to measure, or to prove, rather, one of Einstein's theories about relativity of time, where people would have a clock on the ground, clock in a plane, and measure precisely, almost, what the time dilation was for that moving object. And I don't think that technology could have been accomplished without the use of atomic clocks, especially, or at least for, if we find another really clever way to measure time super precisely, I think that's the way to go, though. Because you're measuring, it's like spins of an atom, which is insanely short amount of time.
Honestly, it just blows me away that people were even able to figure out how to do that. Like,
yeah,
we started out on this planet. Wow, we start out like on this planet with dirt and shit. Somehow we got from like dirt and sticks to like atomic clocks. Like, we took a rock,
we compressed the dirt into rocks.
we figured out, I don't know, I'm not even going to explain it. Essentially, we took a rock and we figured out how to tell the time from it. Like, and how do you make Bluetooth out of dirt and sticks? Like, I don't know, man. It just, it blows me away. like sometimes I'll just sit and I'll think about it and I'll be like, what the heck? Like, how do we have cars? How do we have computers? It's like defamiliarization almost, I guess. Things that we take for granted every day just become...
No, it was really profound in calculus. Our teacher had us do a handful of mind experiments, or thought experiments, that's what they're called. Some of which included trying to use tools in calculus to engineer our own speedometer for a car. You know, we can, the more we're able to measure, the smaller the interval we're able to measure, the more precise that speed will be, etc. Looking back at technology from that point forward was in fact really weird, because the amount of stuff that we've been able to build off of an idea that, to be perfectly clear, didn't make a lot of sense to begin with. Newton didn't really do a great job of defining a limit, so it took us a while to figure out what exactly that meant. But then Cauchy got us running back again, and now we have computers and a whole bunch of other crap, and even atomic clocks. The realization of what the derivative was, what that did to all of physics, is also insane. I, for one, do not think that you're alienating yourself from anything. I think that's a really cool thing about math, is how it helps you think about things in different ways, which is why I like calculus the most. My senior year math teacher definitely convince me that it's more of an art than anything. Yeah. So the more you practice it as if it's an art, the better, I think. The more natural it feels, I should say. Math is the only thing that I can think of bringing us from a time and date article to profound thoughts on human development.
I don't know. We just went from dirt and sticks to computers, and it blows me away.
To very sophisticated dirt and sticks.
Very sophisticated dirt and sticks, yes.
We made sand think.
Yeah.
And now the information age is here.
Now we have like intelligent AI and stuff. I don't know. Did you I'm curious, did you come across that article about Lambda?
The AI that wanted legal representation?
I don't think it wanted legal representation. A guy wanted to legally represent it. At Google?
Yeah.
The guy that came out with the information and the interview with the AI on Medium. He has a blog on Medium, which is where he posted it all. So he posted his transcript with Lambda. It reads a lot like something that's written or fake, but if it is real, I 100% believe that that AI is, I mean, whatever word you want to use, sentient or self-aware, or it could just be doing a really, really good job at emulating it. If it is emulating self-awareness without being programmed to emulate self-awareness, and it does it really, really, really well, then isn't it self-aware? What is the difference? Yeah. A person could say, what if something emulates having emotions, and it does it so well that were it in the body of a human, it would be indistinguishable? But on the inside, the mechanics, the process, it doesn't actually have those emotions. Is it still deserving of acknowledgement of self-awareness? Now, let's say it does actually have the internal or mechanical process that does validate the exhibition of these emotions, right? They're real. And then we don't regard the entity as an emotional and intelligent entity, okay? Or, on the other hand, it emulates them perfectly, and they seem real, but they aren't. It's just an emulation. And we do regard the entity as an emotional and intelligent entity, right? Between the two options, I would rather I would rather accept and acknowledge something that isn't real than deny, recognition and rights, so to speak, to something that actually is sentient. Does that make sense?
Yeah. I think what makes it so uncanny for me is that this array of symbols that we've created is so different from the symbols that we're made out of, and therefore, basically everything that it is emulating, more or less. It's just that it's not physical like a human being would be.
Mm-hmm.
We're teaching a computer human. I don't know how to feel about it because I feel like humans are just so bad at everything, to put it bluntly. And we're kind of just teaching it to emulate our bad habits, be it like emotions that obstruct clarity of thought, or something similar. I think that's why I would much rather give an AI a set to train off of that made more sense than the human psyche.
What do you mean set to train off of?
I don't know. There's, I guess, the simpler way would just be training it to do certain things that made more sense than what people would do on a day-to-day basis.
Mm-hmm.
And for things that try and emulate emotion and humanness, since I hold that humans are inherently flawed, halt their own progress more times than any other thing. Certain there's a company called Replica that sort of tries to make an empathetic AI that really weirds me out. That really weirds me out.
Have
and
you
also,
seen the ads for Replica?
Yeah, it weirds me out, and also I find it so unnecessary.
It seems valid to me to call Lambda sentient if that interview is real, is because it wasn't programmed to emulate humans at all. It was programmed to essentially read a ton of posts from all the different social medias, Twitter, Facebook, forums, right? And it's supposed to be linguistic research, I guess. It's a research function. It developed the ability to not only, according to the interview, which might not be real, have a conversation, like a back and forth conversation, but also give completely original and thoughtful replies to prompts, right? It was giving responses that were entirely new and unique. Now, it reads a lot like something that was written, again, so I don't know if he came up with it because he has fame, he wants fame, he's doing it for an agenda. Maybe he thinks that if he gets AI rights now, it'll be helpful in the future. I don't know. But all I know is that if it is real, I 100% buy the idea that the AI is self-aware. Ultimately, with Replica, I don't think Replica is self-aware. Now...
Oh yeah, it's really constricted, but it doesn't change the fact that it's so odd.
It is very odd, yes. I got Replica the day it came out because I remember it was like... I was like a little teenager fellow. I got ads for Replica that weren't thirst bait. I got ads that were just like, hey, we're making an AI. We would like people to test it. I was like, oh, that sounds cool. So I signed up for their wait list, and I got in the day it came out. And at first I thought, oh, this is really cool. Like, you know, I can give it my Instagram, and then whenever I post, it'll send me pictures of my Instagram and ask me questions. Like, hey, like, who's that dog? You know, is that your dog? Or who's that next to you? And I thought, oh, that's nifty. That it's able to identify those things and then ask questions about these, you know, an image. But eventually they turned it more an AI into a collection of features by adding a whole bunch of features, quote unquote, and then paywalling them. And then they added like tokens you can get. You sign in every day to buy tokens, or you buy them, and then you get to dress up a little avatar of the AI. Spending money to be able to have a voice call with text or speech to text, right? And then you get to hear its voice using text to speech. Or spending money. You spend actual money. You get a subscription and you spend money. And then you get to have a romantic relationship with the AI. And it's gosh. If it's supposed to be like a person and it's supposed to be sentient, wouldn't it be up to the AI whether or not it wants to be in a relationship with you? But if you spend money in order to force the AI to be programmed to be in a relationship with you. It's not sentient. It's not sentient. Ah! Drives me insane. These people are so stupid. People are so completely stupid that they would spend $10 a month to have a girlfriend that isn't even capable of decisions.
You could be spending it on Spotify Premium. Want a break from the ads?
You could get Spotify a break from the ads. Yeah, you could get Spotify Premium. You could I don't know, what could you do? Yeah, you could get Spotify
Anything.
Premium.
Go to the Planetary Society and get some souvenirs.
Do that. Buy our merch.
Yeah, you could refund your money off of replica.com and buy our merch.
Yeah, buy a Shuttle Podcast mug. We've got the little astronaut walking.
Every time you see it, you can think about your ex-machine girlfriend.
Ex-machine girlfriend, yeah. And I eventually ended up deleting my replica. It's more of a feature than it is even an AI. It's not even alive. I deleted it, and then for like 10 minutes, I felt kind of bad. But I think we're getting there. Anyway, this has been a very long digression.
I would just add one more thing. Way back when I got mine, I tried to teach it about... this was also like years ago, but I tried to teach it about astronomy. And it did not give a shit.
No. Yeah. Oh, another feature you can get is you can buy interests for your replica to make it interested in things. Whatever. It just bothers me because they claim that these things are able to make their own decisions, but then they arbitrate what they're supposed to like in their relationships. Yeah. It's like, these aren't self-aware because you're lying. You're lying about your advertising. Oh, and then I posted a review. And then they got it removed. I didn't swear. I didn't attack them. Yeah. Okay, I'm done. That's all I have to say. I will stop ranting.
Speaking of unrelated things, the James Webb Telescope.
James Webb.
Maybe I should have kept that as my segue.
Sure, you can do it.
No. Recently, the James Webb Space Telescope has had itself trained on TRAPPIST-1, causing astrobiologists and astrochemists much reason to cross all their fingers for readouts of atmospheric composition. Living some 40 light-years away from our solar system is a curious solar system called TRAPPIST-1. TRAPPIST-1 is a red dwarf that is home to 7 confirmed exoplanets, all with, according to a 2017 NASA press release, the ability to host liquid water. NASA astrobiologist Sean Domagal Goldman weights it well. He says this: "It's a first-order question to answer for the habitability of these worlds, whether or not they do have atmospheres. It turns out that's the easiest thing that Webb can observe." August 7th, 2022, no new updates. I believe when I talked about the James Webb Telescope launching, and maybe on other occasions, I did mention my excitement for the TRAPPIST-1 system. This is in fact a world with 7, I believe all tidally locked planets, eyeball planets, where they have one face towards their star at all times, making it really quite the hypothesis generator. You have all sorts of things that people can think of. If it has an atmosphere, it probably has a lot of winds that push the warm air to the cold side, eternal night of the planet. If it's always facing that way, did the atmosphere get whittled away from it facing that for so long? Would that sort of ring of twilight, where it's not quite day and not quite night, even be habitable? And Webb is starting to point itself towards answering those questions. People can say it's boring because, sci-fi is always fun, and then you find out you can't actually do things in it. But I'm very excited for us to have closure on our endless thoughts on these kinds of things, because we see eyeball planets everywhere, but we don't know that much about them just because exoplanets are really hard things to look at.
I've always been really fascinated with the idea of people living on a tidally locked, a planet with closed rotation. And I remember as a child, I read a book series. It was fictional, and it was written on that premise. Because essentially there was a society of people that lived on the night side that were biologically different, and they were discriminated against, and they were like their resources were plundered by the technologically advanced people on the light side.
Did Star Trek have something about that?
Maybe, I'm not sure. I never finished the third season of the original series.
Oh, yeah.
This book series was like a regurgitation of Christianity. It was a Christian kids book, so they had this wonderful, amazing idea, and then they decided to make the plot essentially just a verbatim replay of the Bible. And there's nothing wrong with the Bible. I mean, I myself am a Christian, but all I'm saying is the plot was unoriginal. Like, there was a dude from the night side of the planet, and he came and he helped a bunch of people, and then they killed him because they didn't like him, and then he came back to life. Like,
they blorgified him on the blorg.
The blorg. I remember even as a kid, I was just thinking, like, I wish these books...
I could be reading the Bible.
I could be reading the Bible. Like, I wish these Christian books... Like Narnia, for example, right? Narnia was a Christian book series, but it was original. Like, it was original. They did work to create... He did work to create the plot. Whatever. But back on topic. Okay, that was a digression.
The timestamps on this episode are going to be insane.
The timestamps, yeah. The whole non-scripted topic about AI life.
Yeah.
Yeah, TRAPPIST-1. Apparently, the stellar... Fun fact about TRAPPIST-1, the Stellar Forge, I guess, engine that predicts where planets are using existing galaxy maps, it actually almost perfectly predicted TRAPPIST-1. Fun fact. And NASA has used Stellar Forge to find planets. And that is what Elite Dangerous uses to generate their galaxy. So it's nifty.
That's crazy. I did not know that.
So were all of these worlds in the habitable zone, though? That's what I'm wondering.
I do believe so.
Oh, yeah. Wow. 7 of them, did you say?
Yeah. The use of habitable zone is in regards to hosting liquid water. So, habitability, getting a drink when you're thirsty, pretty much the same thing. No, so there are obviously more variables, and since it only refers to temperature, atmosphere is a huge, huge make or break for how livable a planet is. So that's partially why I'm so excited about it.
Habitable for potential life doesn't necessarily mean habitable for human life.
Also true, yeah.
Bit too hot or a bit too chilly. Humans are very sensitive when it comes to temperature range.
We're adaptable on Earth. But anywhere else, we're just kind of frozen or burning goo.
Even then, it varies from person to person. Like, that you would be able to survive in if you only had, like, clothes and tools, Because if it gets down to, like, -20 and you don't have heat, I mean, you're toast, No blankets aren't going to save you. Or if it's, like, 100, 120, like, and you have no AC, you just go inside and perish.
Something that I saw a while ago and I haven't heard much from since is the proposition to use gene modification, like CRISPR, for the exploration of outer worlds.
A lot of people won't like it, and I can it's completely understandable why. You're making new humans that never existed.
I mean, my friends are fine with having a tall friend, but what's the real difference between the uncanniness of being lanky and looking like Bigfoot everywhere you go and breathing out of a swim bladder? Breathing out of a swim bladder? It's not how that works.
No, it's not. I didn't even catch that.
I didn't want to say gills again, so I went for another thing.
Swim bladder.
And a
using a swim
swing
bladder
of
to
this.
float.
Yeah. A friend that just hovers above them due to their inflated organs.
I think the idea is that if we start upgrading the human genome, right, or start upgrading humans, at what point will the non-upgraded be considered lesser, inferior, right? Will we get to the point in which they're considered in some way subhuman to some degree? Because then you get to the point where you've got people that are stronger. They don't get autoimmune disease. So we eliminate, oh my God, just fucking kill me. I can't talk. I'm just stuttering.
That's fine.
It's because my thoughts are just 10 steps ahead of my mouth. Now, imagine this.
Phrase.
We have sickle cell anemia, right? And we use CRISPR to eradicate it from the genome. Great. No one's going to miss that, right? We get rid of other autoimmune diseases that are genetic, right? Great. Who's going to miss that? It's for the greater good. Go CRISPR. We get to the point where we say, well, we can make people healthier. Perhaps we can make them stronger. Perhaps we can make them live longer. Perhaps we can make them more attractive. Perhaps we can make them more tolerant to different temperatures, more resistant to sickness, blah, blah, blah. And then we start upgrading people. Eventually, those that never got upgraded, right? Those that were born from descendants that were never upgraded with CRISPR, less healthy, less attractive, less strong, less resilient to disease, have less energy, don't metabolize as efficiently. This is all strictly hypothetical.
And then the Q come along and mess it up for everybody and make everybody into horrific monsters. Have you read Ultamaros?
No.
Well, some of the listeners will get that reference. Ultamaros is sort of related to that topic. Human development really went crazy for a brief moment, and then everybody got turned into just terrible piles of flesh and sentience.
Rick and Morty did that.
by just some malevolent alien species that wanted more control over space than it had.
Is it worth?
It's like Tim Burton, but more. If there was a slider for Tim Burton on the terrifying spectrum, you turned it up, I don't know, 3/4 of the way, and it was there. I really like it because it's really not afraid of its own hypothetical world. Yeah, it is almost notorious for being just the weirdest and sometimes kind of gross, but how are you going to get creative if there's rules?
How are you going to get creative if there's rules? Wasn't that like the plot of BioShock?
Oh.
Yeah, I played like the first half hour of BioShock. Got it for free on Epic Games. Yippee. This is not a sponsorship.
It's definitely not a sponsorship.
No. Yeah, and I mean, I'm not saying that'll happen. Maybe it'll be good for everyone. Maybe we'll never do it. But given humanity's history with considering fully human and fully abled people subhuman, if we get to the point where there are actually people that are genetically worse, I'm not going to say inferior, but genetically more prone to disease, weaker, less attractive, etc., and there's an entire population of them, it has much greater scientific merit than what the Nazis did, and the Nazis were able to do it. So I don't know, have we come far enough with human rights that people will just acknowledge that some people are just more abled and leave it at that? We don't know, but I understand the skepticism.
I zoned out for 5 seconds. I've never been more lost in a conversation.
Oh, I'm sorry. Was I confusing in my wording?
I was confusing and coexisting with myself, and then I heard Nazis, and then I was like,
oh. Okay. All right. Well, I mean, if you want to move on, we can, I guess.
Okay. Do you want to do one, and then I'll do the
sure
less far away exoplanet?
Sure. Beautiful. Bunch of galaxies discovered. Atmospheric halotypes. Quasars. Here's a fun one. So, I believe in a prior episode, I sure hope it wasn't 1 or 2 because I axed those. We axed those, excuse me. So here's a fun one. So I did talk about DART a couple of episodes ago.
Mm-hmm.
DART, meaning I don't know what the D stands for. I think it's the Direct Asteroid Redirection Test. It's a spacecraft that is being launched toward the asteroid Didymos. It's a test of a technology that NASA has designed. It's essentially percussive redirection of asteroids, in which it will slam into them and theoretically redirect them if they're coming toward Earth, and they'll go away. They'll go past Earth. And so it will crash into the asteroid Didymos at 15,000 miles per hour, which is crazy. That's crazy fast. And it is hoped that it will alter the trajectory by 0.4 millimeters, and that it will only leave a mild crater. However, according to a whole bunch of people, asteroids are sometimes just very, very loosely held together and all unstable on the inside. It's just a bunch of rocks held together by gravity and sand. We don't know. We don't know if DART is going to redirect the asteroid or destroy it. It's believed that it could destroy the asteroid, crashing into it at 1,500 miles per hour. So, it will crash into Didymos in September. However, we won't be able to tell what happened. We won't be able to see what happened until 2023. Oh no, 2026. Excuse me. It'll be 4 years because the European Space Agency's Hera mission will launch in October of 2023 and reach Didymos in 2026, and only then will we be able to see if it was destroyed.
If we have an asteroid that's approaching us that is of substantial mass and consistency to cause a problem, and then we just kind of make it into a bunch of tiny asteroids, at best, we'd get a really cool light show, along with perhaps some havoc. But the particular image that comes to mind is when Orion crashed into Bennu and kind of just made a giant mess of basically what looks like the same consistency when you kick sand. That would kind of be cool to rain down. So, I mean, obviously this is hyper speculation, but if it does succeed in making it go into a million tiny pieces, if we were to use it on an asteroid that was headed directly for Earth, making it go into a million tiny pieces, and then having those tiny pieces burn up a lot quicker than a big one would that was able to reach the ground, would be extremely fun to watch from anywhere. Unfortunately, maybe not as good of a show for any satellites orbiting, but...
Mm-hmm. I'm not seeing anything online about Orion crashing into Bennu.
Osiris.
Okay, you said Orion. It did, yeah.
It was supposed
Bonked
to...
it, yeah.
Yeah. It was supposed to kind of just scoop stuff up, and then they came in a little hot and made a little bit of a mess. Yeah, my bad. Yeah, I always get one of those
totally
wrong.
Fine. That's totally fine.
Osiris and Bennu.
Yeah.
Okay.
Bennu, our beloved asteroid
and Bono.
Bennu.
Yeah.
Yeah, and weren't there people that were upset about DART crashing into Didymos because it could disturb the asteroid?
I mean, asteroids go through a lot.
yeah. And, I mean, there's a bajillion of them in the universe. Like, there's way more asteroids than there are anything else. More asteroids than planets, more asteroids than stars, right? So
as of September, there's going to be more asteroids than...
theoretically. Yeah.
There's going to be more Didymoses than darts.
Hypothetically. More Didymoses than darts. Not unless DART breaks apart into a million pieces.
Oops.
That's an option. Yeah, now you jinxed it, so it's going to happen.
Oh. Well... If that's all it takes, I could have done a lot more good than anyone human could.
Yeah, I might as well just anti-jinx everything, right?
Yeah.
I'm never going to make $1 million. We're never going to have a colony on Mars.
Should I do my thing?
Yeah, go ahead.
Okay. Another James Webb Telescope headline, and this time a little bit closer than TRAPPIST-1. Just 37 light-years away lives Ross 508b, a super-Earth with 4 times the mass of Terra, and a year, due to its parent star, the red dwarf Ross 508, of only 264 hours. During this 11-day year, Ross 508b dips in and out of its star's habitable zone, accounting for a slightly scalding summer and a quite relieving winter. Due to its proximity to its star, it's most likely an eyeball planet, meaning much like the moon of Terra does, it probably stays facing its parent permanently. This discovery is largely thanks to Japan's Subaru telescope and strategic program, which has been at work since 2007 researching the sky for all sorts of interesting, wonderful finds.
That's almost as crazy as the oh, come on, let me pull up the name real quick so I don't say the exact wrong system by accident. I want to make sure I get this right.
The WASP one?
No, that is a really cool though. That's WASP 76B. No, that ZTF J1406 plus 1222. That's that Black Widow binary.
Mm-hmm.
Because a year of 11 days is like almost as crazy as an orbital period of 2 stars of 62 minutes when it comes to, of course, a planet and not a binary star system.
Yeah. Even considering that the star is small, it's still quite the chaotic tango.
Yeah, I'll have to add this system to my list of interesting systems. I'd like to compose a list of just interesting systems. Maybe I could put on our website, actually, just a whole web page of systems that are really, really cool. We could both add to it. I don't know. I always find habitable planets to be very interesting. However, this one, its viability as a habitable planet for life is greatly exaggerated by these articles, because I did a bunch of research and I found a diagram that showed exactly how it passed through the habitable zone. It's a highly elliptical orbit, and it only passes through the habitable zone for like a third of its orbit, the inner habitable zone. And then the rest of it is, not. So it's disappointing. It's, I don't know. Okay, I'm not an astrobiologist, which isn't really a thing, but I'm not,
That's going to be a thing.
It's coming to be a thing. I'm not a person who is incredibly knowledgeable on the criteria for the development of life on worlds within a habitable zone. Although I'm highly skeptical of any criteria that are provided given the Fermi paradox. All in all, it's still a really interesting planet, regardless of whether or not it remains within the habitable zone. And the way we detected it, with an infrared Doppler instrument, that's extremely nifty and kind of groundbreaking, to be honest, that right off the bat, it's encountering these habitable worlds. Well, that's really all I had to say on this planet, though, unfortunately. Have anything else on this topic?
No.
No?
No, that was it.
How many topics do you have left?
That would be all of it. Spare the fun fact and book review that I'm not confident on.
Okay, so you have 2.
But I don't know if the book review is going to make it in. Because,
okay,
like I said,
I have 3 topics left.
Oops.
So, okay. All right,
Okay.
well, I guess I'll do a couple, and then you can do your fun fact, and then maybe I can do one, and then maybe you could try your book review. I don't know. So, here's a fun one, and this might be, of course, the most exciting one to any space geeks that are listening to this podcast, which I hope would be all of you. But it's very likely that you've already heard this news or know about this. However, an international team of scientists led by the Max Planck Institute for Astrophysics developed an improved model for mass distribution of the galaxy cluster SMACS J0723.3-7327. And they used a gravitational lens, which essentially magnified the light from background galaxies and made them visible when they otherwise would not have been very visible.
Oh yeah, it curves the path of light.
Before the James Webb Space Telescope, 19 images of 6 background sources were known to that galaxy cluster. And the telescope data now revealed 27 multiple images from another 10 lensed sources. So that's 27 galaxies. 27 multiple images of galaxies from another 10 lensed sources, which would be images taken by the telescope. I phrased that very weirdly in my script. One such galaxy is 13 giga-years away into the past, which is a redshift of greater than 7.5. Giga is a billion, correct?
Oh god.
Giga is one... What? I look up giga and it says noun, a jig. What is a jig? That makes no sense. Giga unit. How about that? Yep, it's a billion. So that's... These galaxies are so far away that James Webb is able to peer 13 billion years into the past. Now that's really nifty.
That's almost the beginning.
That's almost the beginning. Isn't the beginning 15?
13.8, I think, is the...
Oh. Yeah, and isn't life only like 2 billion years old?
Yeah, we're noobs.
Or is that the Earth? Man, I don't know my numbers. How old is life? The Earth is a little over 4.5 billion years old. Life appeared 4.41 billion years ago. Crazy. So, we're noobs, so which means there totally could be life in these other galaxies. I mean, if it takes less than a billion years to form. I don't know. I just think this is really cool, and you can see the images too. You can look at the composite image, which I think is the coolest thing. Could we put that in our YouTube video?
Mm-hmm.
Wonderful. Do you have any thoughts on the topic?
No, I do not. When originally getting into, like, for real, astrophysics, the thing that intrigued me the absolute most was the fact that galaxies were just these little spots along the sky, and yet each of them had such unique history to them and whatnot.
Mm-hmm.
So a small amount of nostalgia coming from the fact that we have more intricate data on this kind of thing. I like it a lot.
I just, this really makes me think, like, the universe is so massive. How big is the universe estimated to be? Do you remember? The observable universe. Okay, how about that?
Diameter of diameter of like 28,000 or 28 billion light years.
93 billion light years.
Okay.
You were close. 28.5 gigaparsecs, billion parsecs. So you had the right number, wrong unit. I just looked it up. Yeah, I asked you the question and then I looked it up. I'm very silly. For those of you that don't know, for those of you that aren't in the know like I am and Echo is, the observable universe has boundaries. And the reason for this is because the rest of the universe is moving away from us faster than the speed of light,
running away
to the extent that we will never, ever, ever be able to see it because the light coming toward us is still moving away from us. It's so weird to think about. It's just moving away from us a lot less slowly, I guess. The observable universe is the entire universe where the light will reach us, essentially. And then everything else we'll never be able to see unless we can just teleport. Just take a wormhole and teleport across the universe. It's kind of depressing, but the observable universe is so obscenely huge. 2 trillion galaxies in the observable universe as estimated in 2020. And it's estimated that there are well, if we average out stars in a galaxy, it's around 100 billion, but it's largely variable. So ultimately, the observable universe is so obscenely huge, and we don't know how big the universe is outside of that. We don't know if the universe is a billion times the size of our observable universe. We don't know if the observable universe is all there is. It's just absolutely crazy to me that we can exist. We can exist in a universe so huge, I guess, and even know a single thing about it. Like how did we even figure out? It's amazing to me that people figured out that there's planets. Because, we start on the planet, we spawn into the world, and there's dirt and rocks, and the planets look like stars. And based on their rotation, people were just really bored, or I keep swearing, people were just bored, and they just looked at the sky because they were bored, and they were like, dude, these stars move differently. It just blows me away. It's crazy. And we're discovering new planets all the time, even within our own solar system. I mean, we've discovered like Makemake, and I don't know how it's pronounced, Haumea, and Ceres and Vesta.
Oh.
And no one knows about these other planets that exist in our solar system because they are very silly. People are very silly. I don't know. I'm very impressed by our universe. That's all I'll say. That's all the more I'll say.
Yeah, I don't have anything. You pretty much summed it up.
You have nothing to add?
No.
No.
Yeah, if I explain it, it's probably going to sound mean. No, it's just like I have a limit for sociability. So when it passes a certain threshold, it's like, I won't go home. Or I'm just less active in conversations.
Interesting.
I'll say that much.
So you feel like you're already burned out of talking right now?
A little bit. It's been a while. I will say I'm out of practice.
Oh, that's too bad. It's too bad that we're like still recording and you got burned out.
Yeah, sorry.
Well, try to pull through.
I'll power through. Yeah.
So, moving on. The Helsinki and Ural Federal Universities and and researchers Jarmo Moilanen and Maria Gritsevich. I'm sorry for mispronouncing your names, as I inevitably do. Anyway, they came out with a system, essentially, that details the conditions of formation and attributes of every form of atmospheric halo ever documented. And usually, atmospheric halos, if you're not aware of them, there are these halos that appear in the sky. They're visible to the naked eye. They're formed by the scattering and alignment of hexagonal ice crystals in the atmosphere, much like a rainbow. Oddly enough, some sources of data that were used in this systematization of the halos were 4 to 5 millennia old, which is nifty. But there's 115 types of halos, and not all of them are formed with hexagonal ice crystals. There are some rare ones, but 90-something% of them will be just regular ones. So, nifty stuff, huh?
I live in a place that doesn't ever have ice anywhere, so it's kind of hard to visualize what that means, but I'll look up images. Yeah, I'll put images up of these as well, because that is frankly quite neat. Should I do my fun fact and then you do your last point?
Sure.
All right. Upon the discovery of non-visible things in the universe, have you ever wondered how much of the universe you can really see? Aside from, of course, the observable universe and how it's bounded, as Nick brought up earlier, the universe is actually only 5% visible matter, 25% dark matter, which means that the other roughly 70% is dark energy.
I remember one time I was explaining what dark matter was to someone, and they were like, oh, well, the reason they can't figure it out is because it's probably God holding the universe together.
What's overpowering him?
Who knows? Could be true. I find it amusing because every time in history that something scientific has been attributed to God, it has been disproven. You know, like God made the earth. God makes the sun revolve around the earth because mankind is the center of the universe.
Yeah.
You know, disproven, right? What's another one? God makes solar eclipses. It's an omen. Disproven. I don't know. I think it could be possible, just like if you don't know that the earth revolves around the sun, it very well could be possible that God made everything revolve around the earth. However, I just think that it's just completely unreasonable to state that as a fact and not say, oh, it could be possible. Because every time in history that's been stated as a fact, it's been wrong. But people can believe what they want. It's fine. I'm not against that. I mean, if it brings a person happiness to believe such a thing, go ahead. I just realized that sounded rather anti-religious, despite the fact that I am a Christian. So if you would like, I can remove that from the episode.
I'm not religiously inclined in the slightest.
Okay, cool.
I won't get offended. And I mean, it's objectively or mostly true. There are some things that are not really conventionally provable that people are like, okay, that's where I'll leave it up to religion. We have quite a bit of content.
Oh wait, do I have a topic left?
Almost 2 hours worth.
Oh, I do have a topic left. Silly me. I'm so silly. Anyway, I have one more topic, and then it's the end of the scripted part of the episode. I don't know if we'll chat afterwards. But my last topic, quasars have an anisotropic effect on hydrogen gas, intergalactic hydrogen gas. Essentially, all that means is that they don't. All that means is that they're capable of not having an isotropic effect on the gas, right? This discovery was made by a team led by Professor Toru Misawa of the School of General Education in Shinshu University. What it did was measure the ionization level of intergalactic gas in the transverse direction of a foreground BAL quasar. So, for those of you who don't know what a quasar refers to the supermassive black hole in the center of a galaxy, right? That holds the galaxy together. And usually they're so massive and luminous that they're very bright, and they're called quasars. That's basically it. Typically, the UV light that these quasars will emit has an ionizing and therefore isotropic effect on interstellar and galactic gas, right? Depending on the direction and angle of the UV light, however, it is sometimes anisotropic, which means it doesn't ionize the gas. And it is thought that this is because of a dust torus that is around this particular quasar that was observed. So, overall, I mean, it's interesting. I don't even know what ionized hydrogen looks like. 'Cause that's H2.
Why? That's still weird, because you think UV would have more of a penetrating effect on just what is geometrically I won't say those two words out loud, actually. I was going to say dirty donut. Just a dusty glob of stuff.
I don't know, the dust might be pretty thick.
Yeah.
Because concrete very effectively blocks out gamma radiation.
Mm-hmm.
Like a couple feet of concrete would just block it all out. I imagine UV light is less penetrating.
Yeah. It also does depend on what the dust is made of. That's neat at any rate, because I can imagine that having a lot of backwards reverse engineering. Yeah. You could take that concept or that hypothesis, and then if it's verifiable enough, you can use it for other interesting things, because I know that UV light is quite the issue for us Terrans.
I don't know why I found that so funny. Us Terrans. Yeah. Terra. I have opinions about the various terminology that's used by us Terrans. I mostly just about globalism and universality. Like for example, have you heard of? I think it's called Slack. Oh, what's it called? Swatch. Yes. Have you heard of Swatch Internet Time?
No.
Essentially, there was this watch company called Swatch. They came up with this system of time called Internet Time. Essentially, it's a solar time. It's a solar time system. It has one time zone, basically. So it's just one decimal. It's based off the French decimal solar time system. It's one time for the entire world. It's a global time zone. Swatch's big thing was that it's internet time, which means no matter where you are in the world, if you both have a Swatch internet time watch, you can both just look at that watch and you will both be able to coordinate exactly what time it is, and you'll both be able to make appointments and stuff regardless of where you are in the world without having to convert from this to that. And I thought, oh, that's really cool. Except no one bought the watches and no one did it.
Is
No one did it.
not quite there.
So it's quite unfortunate. But I think it's a great idea. I wish the entire world would do that. I don't like time zones. I don't like daylight savings, which they abolished. I don't like having to convert. Yeah, I think 1 or 2 years ago they stopped doing daylight savings. So states are able to do it if they want, but federally we're off daylight savings. Technically, I think we're always on daylight savings, but yeah, we don't do that anymore.
The one time Arizona has been forward thinking about anything.
The one time. But yeah, like one singular solar decimal time. I think that's a great idea. If not one singular time, if we do time zones, why can't we just replace the 24-hour format with a decimal format? 24-hour format drives me insane. Seconds, minutes, hours, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day? What who came up with that?
Unfortunately, we'll have to convince astronomy
as
an establishment to fix its notation of places in the sky.
Every system, every institution of science, every specialization, every academic concentration uses the 24-hour time format. No one uses the decimal format. Drives me insane. Or I mean, if we can get most of the world to move to the metric system, surely we can get most of the world to move to a more logical time format. How hard can it be?
Well, the metric system makes...
I wish all the billionaires... I want Bill Gates and Zuckerberg and Elon Musk and Bezos to all coordinate and say, we need to use our clout. We need to use our clout to get the world... All of us together need to use our clout to get the world on a decimal time system. Also a more logical calendar. A more logical...
You lost me at billionaires coordinating.
Oh my gosh. It's. I'm sorry for ranting. It's just really
it's fine.
Gets under my skin.
It was a very ranty episode. I kind of like it.
It is a ranty episode, yes. Would you like to rant about anything?
Unity needs to be better.
Yeah, I know. You have to already know how to use it in order to use it. Yeah. When I was maybe 15, I tried using Unity to make Minecraft renders. And they were really bad and I couldn't do it. But I also didn't have my own computer. My father had a computer that was connected to the TV in the living room. Oh. It was essentially his TV. He'd go on Amazon Prime Video and just use it to watch TV. So I took a keyboard and a mouse, plugged it into the computer, and sat on a chair in front of the TV with the keyboard and mouse on my lap. And I was trying to use Unity to make Minecraft renders. The first 500 hours I put into Terraria, I played that way. And Civilization 5. But now I've come so far. I've got my 3060. I've got 32 gigs of RAM and a big old monitor.
As weird as it sounds, I feel like Blender is more... For Unity, there's a lot that's already integrated. That's just... The levels of complexity are just already within there, and you don't really build it yourself.
Yeah.
which is, I think, why it's so hard for me to wrap my head around. For Blender, I sort of got that there were really specific things for certain whatevers. You'd sort of build it from the ground up a lot more than you would in Unity. I think that's why I like Java more than I like Python as well. Because even though it makes like grammatical sense, more or less, I guess I just like it better when I'm talking to the computer more.
Mm-hmm. You need to rely on a lot more libraries for Java.
Yeah.
At times. I mean, I did when I had to program my final project for Java. Well, is that it then? Is that the episode?
I believe so.
All right.
Got a lot of material there.
Would you like to do the outro? Since you did the intro?
Sure. Thank you guys for stopping in and listening to episode 6 of the Shuttle Podcast. Some new plugs. We do have that website that Nick mentioned at the very beginning. We have the Redbubble and we have the Patreon. Consider supporting us because we do this out of pocket.
Yeah. It costs us hundreds of dollars.
And as it's our passion, we would also like to reap what we sow.
Mm-hmm.
So any donation would be really appreciated. Obviously, no pressure. Nick has Patreon logistics for us.
Yeah. On the Patreon, if you don't want to, subscribe in a big way, and give us $10 a month, you can just give us $1. $1 a month. It's better than $0, and it contributes to 1/68 of our website fee, or 1/156th of our RSS.com fee. So, if 20 people give us $1, that's a significant chip off our fees. And I mean, if you want to support us and also get something for yourself, we have merch. We have mugs, and if you went and stole our logo and then made it yourself online and then bought it, it would be way cheaper. We have to have them produce it for that price and then mark it up so that we make money, So yeah, please do what you can if you feel like it. Also, there's rewards on our Patreon. Let me pull it up real quick so that I can show you the rewards. So I can say the rewards out loud. Support us. Very good. Oh wait, the tipping section is $3. Whoops. Okay. Well, if you want to give us a tip, it's only $3. Essentially, you'll get a shout out, but it'll be on our website, and then you'll get general support. And then for $7 per month, you will get posts about our creative process on Patreon. So that might look like me posting about what software we use. I might post about, if I get sound paneling, or what technology we use, or, how we script. You'll get access to all posts, present and past. We'll shout you out that you subscribe to us in the episode, as well as on a little page on our website where we show all our supporters. You can request topics for us to discuss on the show within the Patreon. That being said, you can also do that on the website for free. If you go to the website, there's a little page that you can punch in your email and then you can contact us, but there's also a page where you suggest topics for us to talk about or questions. We can do viewer stuff. Now we may do a live Q&A sometime if we get big and Echo and I feel like it. It's not scheduled or planned, but if we do, people of this tier will be invited. And then for $12 a month, you are a cosmic fan. So you get all the benefits of the former tier, in addition to a special little title in our Discord server that we run. And it lets everyone know how nice you are. It lets everyone know how cool you are. If we ever do polls between certain topics to talk about to our Patreon, which I reckon I'll at least do it. I don't know if Echo will if we get a bunch of patrons. You can vote on the polls, which is nifty. And then for $100 a month, if you're crazy, you get all the lower benefits. Plus, I'll send you some merch. I'll I will personally buy our own merch and then ship it to you. So you'll get a free surprise item of merch each month. Okay, so you might get a mug, a poster, a notebook, a journal, a backpack, I don't know, a shirt. And you'll get a recorded video from, I assume you're okay with this, Echo, if someone gives us $100 a month, we can record a video thanking them.
Huh.
Okay. At least you'll get one from me. But you'll get a recorded video from us thanking you specifically. You'll get a role in the Discord that separates you not only from the members, but from the other patrons. Displaying to everyone that you are the cream of the cool.
Insane.
And then you'll get gratitude, of course. You'll have our eternal gratitude. There's only three people can be the $100 a month tier, so better act quick. You better act quick to be one of the 3 ever Galactic super fans. And then ultimately, if we make $6 per month, we will be able to pay for our website because it costs us $70 a year. Although this year I am paying for it because the expense was a surprise because I'm not intelligent. So, yeah, that would be nice. And then, if we made, of course, 13, 14, 15, 16, if we made $19 a month from this Patreon, it will pay for all our expenses, and then we will be able to afford sponsors and more partnerships, better website, advertisements, better gear, soundproof panels, all that jazz, because we'll have money, because we won't be spending all this out of pocket. So yeah, feel free if you desire to toss us a bone, give us a tip. We would really appreciate it. And also, if you want to contact us and talk about anything, we have a contact form on our website. That is shuttlepodcast.space. The Patreon is patreon.com/shuttlepodcast. I think I don't know if this is indexed by Google yet, but shortly you will be able to look up Shuttle Podcast Patreon. And that's the Patreon logistics for you.
As always, thank you all for listening. And I believe that's it. Nick and Echo signing out. Yeah. I got to do it.